Sorry, in the last class I got disconnected because my battery drained out, laptop battery, and the charger was also not there in my office, and all of a sudden I need to stop the class. Okay, so we have started the basics of operator overloading, and now in our last class we discussed about the overloading of binary operator plus, and what we found. So we took the example of user defined complex class, and as we found that we'll having, say, if it is 2 plus 3i as a complex number a complex number b, say minus 2 minus 4i, c may be a complex number 2 minus 3i. So each of these complex numbers, which will have a real part and an imaginary part, a real part and imaginary part, like this. Okay, so we need to store the real part and the imaginary part as two main data members, and apart from that, amplitude, modulus, and all this will be there. So that's why we did declare these two private data members, so that the original real and imaginary values cannot be changed, so that the number remains intact, but we may decide to consider the argument and amplitude to be public. And this is the constructor and this is the destructor. These are trivial things. And if I write the simple class, so this will be the display function, so which displays the contents, and we have got this type of display, so that it appears to be 2 plus 3i. So we get the display something like this, which is how we prefer to view it. Okay, or in case if the imaginary value is negative, so it will be like 2 minus 3i. So that's why if imaginary value is greater than 1, greater than 0, we have displayed this, otherwise we have displayed minus, and then we have considered the value. And the destructor is trivial. Okay, so then the subtract complex. So this is the normal method without any overloading of operators. So this is how it works. So if we call the subtract complex, so it invokes this method and it works. And then we came to the case of binary minus operator overloading. So if we write like this, d assigned a minus b, then it will be translated to d assigned a dot operator minus b, because the compiler translates it to the special function which starts with a keyword operator followed by the symbol. And just to make sure that it indeed translates it, so let us try this one. Is it visible, the code?
Yes, sir.
Yes, sir. So can you see that it has got a constructor, it has got a destructor, just now that I mentioned, it has got a display function, and it has got a subtract complex function method. And then these are the details of it, because these are member functions, we wrote it with this these things, and this part I comment out. So here, so will this line 75 work?
Yes, sir.
It will work because we have got a function this in line number 40, right? And but will this work, line number 77? Did you overload anything?
No, sir.
So if I compile it, let's see how it what kind of comment it provides. So complex operator binary. Okay. Okay, can you read the error messages? What is the main error here?
No match for operator minus.
So can you see what it prompts or what it expects from you as a programmer? No match for this. So it interprets operator minus to be what? To be a method that should be included in your class definition. Is that part clear? So did I write the keyword operator here anywhere while calling? No. So this proves that it translates it to this one. It translates it to C equals A dot operator minus B. That is the reason it is expecting this operator function, and that is shown here. Is that fine?
Yes, sir.
So this gives you a proof that indeed there is some kind of translation, and because of that it is expecting you also to write something like that. Okay, so in that case, if we write now, if we enable that operator function, operator method, the details we have already explained. So it includes, you see is there any difference in the body of the function?
No, sir.
It's exactly the same, only the name of the function is different, and all those things are different. Other than that, everything's same. So you write here member function, you write here member operator function. So just to distinguish between these two. So if I run this code, hopefully it will compile, and this is the output. So can you see that it is invoking both of these two? So in line number 77, it invokes member function constructing an object, a complex object. So why it is giving this prompt? Why it is giving this prompt in line 75? In line 75, what is happening? It invokes this one. So member function. How come that part appear? Constructing a complex object.
Because we are creating a static object in the function.
Is that part clear? See, there is a static object creation. So this triggers. So any object creation means a constructor will be invoked. So it actually invokes this constructor. So constructing a complex object. So that's why it is coming. So this gets this appears after this member function prompt. Is that fine?
Yes, sir.
So this is the invocation of the member method, which actually tries to attempt to subtract two complex numbers. But before it does that, it creates a temporary static object, complex object, which will be returning. So that's why that triggers this construction, this invocation of the constructor. Is that fine? So next, what happens here when you call when this line 77 gets executed, what do you expect then? It will trigger this function. What will be the prompt? Member operator a minus b, this minus function. So it's operator function, that's why this prompt comes, and then again it is followed by the static complex object creation of t. Okay, so that's why this constructing a complex object again appears. And finally, we just try to display the resultant complex object which we obtained after the subtraction. So that is what this is. So this is, we can check it that the values are correct. Now how many objects need to be destroyed here? How many objects got created actually? A, B, C, and what else?
Two static objects.
Static objects, two of the static objects. Okay, so that's why four of the objects get destroyed. Now can you tell me, if I write here C equals C minus A, will it work? If I write C equals C minus A, will it work?
Yes, sir.
So if I run it, can you tell me what will be the output here? Can you tell me what will be the output?
So can you show the code again?
-3 -5i.
Yeah, I'm not interested in the display function, in the display complex, but I'm interested in knowing how many destroying objects will be destroyed. How many objects will be created first of all? Can you tell me how many objects will be created if I add this line 77? Or in other words, you can also answer that how many times this destroying a complex object will appear. How many times a destroying a complex object will appear? Earlier it was 5 times. Will it be 6 times now? Is my question clear? Hello?
Yes, sir.
Anybody with the answer? Will it be 6? Hello?
So it will be 5, I think.
Why it is 5? Why not 6?
Because C is calling that same function, and that static object that was there, it will not be recreated.
Others, can you follow? Other students? All of you took so much of time to answer this. That is not good. So it will be invoking this. So both 77 and 78 will invoke this method. That is correct, right? That you all agree? Hello?
Yes, sir.
But the static complex T, so any static variable within a function, if the function is called repeatedly, will it be created repeatedly and destroyed each time?
No, sir.
No, sir.
So you know the difference, right? So static say variable within a function will be constructed or created only once, and it retains the value, and it gets stored in the data segment, and no matter how many times you enter, the same value is retained. Unlike a normal local unlike an unstatic local variable. Is that part correct? You all agree with that, right?
Yes, sir.
So that's why this static complex T, it will be created only once, no matter how many times you call. So that's why both of these will be called, but once only the corresponding the object T will be created. That's why it is constructed also once and also destroyed once. So that's why it remains again in 5, not 6. Is that part clear? So that again proves that static are not created each and every time you enter the function if it is a static local object. Okay. I guess that's fine. So now we come here and we find that this is the translation, and this is the corresponding operator function that we have that we have to write, and this will trigger this one. So when I write this here, it gets translated like this, and it actually triggers this particular body.
Sir,
Yes.
sir, can you illustrate that example of the earlier example that you used 3.5 minus a with the code?
We want me to get back to the code. Okay. Yes.
So the example that you used in the class earlier, that 3.5 minus a, can you illustrate that same?
3.5. Yeah. What is your question? I'm not getting.
So in the last class, you used that example like a is equals to 3.5 minus a.
Okay. I'll come to that. Sure. I'll come to that.
Yes, sir.
Because in the last class I was a bit unorganized and then I could not show it. Yeah, I'll come to that. Sure. Just hold on. What is that? Okay, so is that part up to this? Is it clear?
Yes, sir.
So what I illustrated here is that so that you really get convinced that the compiler translates it as operator minus, so that we have found the error message from the error message. Second thing is, if I write something as static, that is constructed only once, not multiple times as we enter, and if I pass the static uh, local object as a reference, then this also works, that you don't avoid so you can avoid creating the uh, temporary objects. Okay, one thing we can once again check before proceeding further, this one. So if I would have not made it static, see, so what is, or maybe this thing. So if I would have not made it like this, okay, and so what would have happened? Got the change what I made?
Yes,
Got the
sir.
change what I made here? So constant complex ampersand c instead of that. So I'm what I'm doing here is instead of passing the reference of c, reference of this variable b, I'm passing the the value of that b. I'm passing the reference of that b. Do you accept that? This one.
Yes, sir.
So if I compile it and run it, what do you expect? Will there be any change in the? Okay, can I make? Oh, it doesn't match with the prototype. So prototype also I change. So can you comment? Will there be, if there will be any change here in the output?
No, sir.
Hmm?
No, sir.
No change. There will be no change. So in the previous case, and if I make here instead of the static, so how many? So is there any change now?
Yes, sir.
What is the change?
More objects are being created, so destructors are more.
Can you see the fact? Everybody, can you see the fact? So if I make, if I don't pass the reference, see, if I don't pass the reference and I just pass the value of an object t, so that also will work. But in that case, a temporary object is created and destroyed. Okay. So why there are two objects getting destroyed? Because twice we are calling. This time 2 times, this time 2 times. So for each call, it is destroying two complex objects. Why?
Because while passing, it gets created a temporary object, and while returning also.
So can you see this? So this is the overhead that we incur if you don't pass the references. So if I pass the references, it is not only so it saves some time, and also it avoids all those unnecessary comments, I mean prompts that appears. So this is the case. I have to make the change here also. So this is one thing that I wanted to show you. So now if I compile, okay, oh, that should be made static. So we get rid of those destructors called of the destructor calling when the operator function is getting terminated, or it is the control comes out of it. So those temporary objects or the static object, I mean, in fact, those temporary objects are no longer created or destroyed. Is that part clear?
Yes, sir.
So this point I just highlighted in my last class itself, that why I should be more inclined to return the reference, and if I would like to return the reference, obviously I have to make it static, and if I make it static only once it is constructed, but in the future calls that remains intact in the in your data segment, and you avoid the destruction also every time. So are these parts clear? Now can you tell me that if I have called, just a minute, so one option is this, we have already found, sorry, this option is there, and how it is done we have already found it. Now is there any other option where I can still invoke this operator function but without having it defined as a member function? Is my question clear?
Yes, sir.
Because it's a member function, you see, using the dot operator, using the argument, the first argument a, I am invoking it. Now is there any other option of writing an operator function? So the compiler asks for operator function, and you have to provide operator function, that is confirmed. But instead of providing as a providing the operator function as a member function, as a member method, is there any other option?
As a friend function.
So we have already found that, but again the problem, the fact is that function should have access to the real and imaginary, which are private members of that class. Okay, so it should not be a member function, still it should enjoy the access to the private members of it, so that addition deletion involves those members. So the only option is, so now the one that we discussed, the concept that we discussed, we can rely on declaring the operator minus the method to be as a friend function. Is that part clear? Is that part clear to all of you? Hello?
Yes, sir.
So what
Yes,
do you
sir.
think? What will be the translation then? So if the compiler first of all will try to translate it in this form, and it will be done only if it finds a copy of a member function named operator minus. If it is not there, the compiler will try the other option of translation. So what will be the translation then? What do we expect? Operator minus. If it is a friend function, then how many arguments will it take? What do you think?
2. 2.
Because both A and B need to be then passed, right? Because A is not invoking that, unlike the previous case. Rather, the friend function will accept both the operators, both the operands A and B, right? So both A and B need to be passed as 2 arguments, and whatever it returns should be assigned to C. So this is the alternative translation that you will try. Okay. So either this white translation or the yellow translation. So this is the first. So this is the first option, and this is the second option for the compiler. Is that fine? Because this is also possible, right? Is that okay?
Yes, sir.
Everybody agrees to that?
Yes, sir.
So both are possible. So if it is possible, because so I just once again highlight those. A friend function is a non-member function which can still access the private class members, don't need an object to get invoked, not referred through class scope, requires a class object. This is not visible. Requires a class object to be passed as an argument to be declared as a friend by the class. Okay. So in that case, what we expect, this operator minus, what we expect in that class, in that complex class, when you write the details of this function operator minus, can you tell me what I need to write here, the details?
Initially MP4 operator minus friend complex ampersand.
Can others also tell? So it will be operator minus. Now there are 2 arguments. One is, say, let us call it as x, and this is y. So what is x? X is what?
Complex reference.
Complex reference, and this is also
Complex reference.
complex reference. Now I would additionally like to make them as constant, right? I may do that. I may or may not. I may do that. Tag is as constant so that the constantness of the original A and B remains holds there. And here, what it returns, this operator function, what it should return?
Complex reference.
Right? But above all, this whole this thing, this operator, this function need to be declared as this need to be declared as is that part clear? Hello?
Yes, sir.
So
Yes, sir.
so either your compiler will search for the previous type of code that probably you have written. If it fails to find it, it will try to translate it. But before it translates, it will make sure that something like this is there inside your class code. If none of them is there, it will definitely give a error message that has popped out as we have found. Okay. So here this is what it means. So this is so if I write this, The alternative can be, okay, it should be operator minus a comma b. Okay, so that would have triggered this. So if you have got this body of function with this prototype declaration, then also it will work. So either the previous option or this option. In both case, this syntax of calling is will work. Okay. Now, where do you declare this details of the friend function? It can be either inside or outside. That does not really matter. Is that part clear?
Yes, sir.
Now, this is a question. Can you see? Can we have both the options? So this is the type of call that I would like to have. Now I have included, so this can be either translated in this form or it can be in this form. So if I have both the bodies, will it work? So if I have included this also and this also, either one could have worked, but I have included both of it. So will the compiler will get messed up? What do you think? Will it be supported?
No, sir.
Any other answer? Anybody else?
So maybe the member function will be checked. If it's not there, then
Yes. So let us have both of them and then see that how it works. So I've included this and this, both the possible implementations I have included just to support this kind of calls, right? So let it be just one call only. So let us see if it is getting compiled or not. Okay, now it gets compiled. That means the compiler has no objection if you put both the possible options. But then what do you think? Which one will be actually invoked? Can you see this? Can you see which function, which copy is getting invoked?
the member part.
See, for the friend, I have given the prompt friend operator function. So if both are present, then this will be preferred or this will be first checked. Is that fine? Hello?
Yes, sir.
So at
Yes,
least
sir.
from the compiler's perspective, there is no conflict. The compiler says that still you can have two copies. I don't, uh, because so there could have conflicts or there could have ambiguities, but the way the compiler has been written by the C++ designers, so they thought of having both the option because the compiler will try the first option. That's why I mentioned this one. So the first option for the compiler and the second option. So that is in a specific order. It's not like both will be treated, because it will prefer if you can have some solutions using just member functions, it is better because then it is more encapsulated or it is more object oriented like that. But the other option is also accepted. Is that part clear? So can we have both the options? Yes, the compiler matches the member function first, and in that case, this will be displayed. Is that part clear?
Yes, sir.
So now let us come to this part. A minus 3.0. So in this case, what do you think? What will be allowed? Can we have both the member and non-member function, both the friend function and the member function option, which can be exercised here?
Yes, sir.
So there is also no problem. Okay, so here what it means, I can either have this option or I can have d equals operator minus a comma 3.0. So in this case, what will be the prototype here? What will be the prototype? operator minus. Now if I go for the first option, the member function option, so what it will accept?
Floating type.
Say float some x or whatever, and it returns again the same thing, complex. Okay, so the details we can write. And what it means here, maybe the interpretation is like, because it's a complex number, say x plus iy. So if you would like to add some float value, say like plus 2.5, 3.2, so this will be added only to the real part, and this will remain unchanged. That's why we have mentioned added or subtracted, whatever. Okay. So is this part fine? So, but here we can have the other option also. What is the other option? So other option is I have to write the friend function. So in this case also both the options can coexist without any conflict. The compiler will try them one by one in that order of preference. Okay, so this is what will be the prototype here, complex ampersand, say C, and then this float F. And what will be here, complex ampersand. What else we are missing?
Friend.
So this is a member function option, this is a friend function option, this is a friend function option, and this is a member function option. So I have to write here friend. And here also I have to write, so there will be no friend keyword when you define. So this will be just complex ampersand. Now because it's not a member function, so I don't have to write this part, right? So this part is not required here. Rather I should write what? Operator minus, and then complex ampersand C float F. What will be the body here? Again static complex T. Then what should I write? T dot RL equals assigned T dot RL is, hello,
C dot RL minus F.
C dot RL minus F, and T dot imaginary equals, this is assigned C dot imaginary, then return T. Is that part fine?
Yes.
Yes, sir.
So both can coexist in this case also. But let us try this one. Now what it says, so this gets translated to, so if I try to translate this, so it's a option, first option, the second option. So in the first, if I try to translate in the first option, now it will be D equals 3.0 operator minus B. So this is not valid. So this 3.0 dot, so 3.0 is not a object. So in this case, can the first option exist?
No, sir.
So in this case, the only thing is the second option can work. So then it will be 3.0 comma B. So my question is, if you have already included this friend function, if you have already included this copy of the friend function, will it take care of the next, so this syntax?
No, sir.
In this friend function, what it accepts, the first argument is a complex object, second is the float. But in this case specifically, it requires the first object to be a float, second object to be a complex object. And in fact, these two differs. So this friend function has been overloaded here. Got the point?
Yes.
You have to write an explicit copy for this. So this will be only translated to D equals operator minus A comma 3.0. So this is the only option. So this friend function is the only option here. So we'll have the prototype as friend complex operator plus operator minus complex C comma float F. Is that part clear? Is that part clear? So somebody who was asking about the question.
Yes, sir.
So what we can conclude here is if you have got binary overloading, putting all the possible cases like this one, and this one, all the three cases, A minus B, A minus 3.0 and 4.5 minus B, all the three possibilities. So if you would like to support all these three possible calls, so in the body of the function, as you can see, so which one matches? So A minus B, so it will try to find out. So if for A minus B, there can be both the options, member function, friend function, but you have included what? What is this? It's a member function option, right? So it matches. For this A minus 3.0, it will first try to go for a member function option. Is it there? Is it there where you accept a complex object followed by a float using member function? Or in other words, do you have a member function which accepts only a float?
No, sir.
So it will then go for the second option, and it finds that there is a friend function corresponding to this. So here we have got a member function option. Here we have got a friend function option. And for the third case, there is the only option that is to use a friend function option. Okay. I could have made it more explicit by adding the other option here and the other option here also. But it is enough to have this much. So putting all possible options together for the binary minus operator in the class definition, opting for the friend function instead of the member function for this particular case. Okay. Any question till this point? Any queries till this point? So the point to note is, so this is pretty simple. So the only thing is you have to note that we have to declare a static member, a static object, and we should prefer to return the reference of the static object instead of the value to save some bit of overhead in creating and destroying the temporary objects. So that is another part need to be known. So these are the few things that we can summarize. Use of an overloaded binary operator with using for user defined objects gets translated to a special operator function with the name this, where this caret is being the name of the overloaded operator, like minus, plus, or whatever multiplication. So syntax means if I write A minus B, then if the function name always will be operator minus. In the first case, we have got the member function and the friend function, both the options. In the second case also we have got both the options, but in the third case we have only the friend function options. So one can add both the options simultaneously. Availability of the member function is checked first. If not found, only then it searches for the friend function option. And to make it possible, the behavior of the operator function need to be defined in the class definition. So that we have found. A binary operator function takes one argument, the second argument, when implemented as a member function. When implemented as a member function, You see, the second argument is passed as an accepted as an argument in the method. Okay, in this case and in this case. A binary operator function takes two arguments, first and the second both, when implemented as a friend function. So when you implement as a friend function, both these as are accepted as an arguments in this case. And the difference with the friend function call, function does not appear inside parentheses. But instead surrounded or are next to characters. So the thing is, it enhances readability as we found. So what about the unary operators? What can be the interpretation of this? Say it is 2 plus 3i. Say it is a. If I write minus a, what do we expect?
Minus 2 minus 3i.
So if I write minus a, I would expect minus 2 plus 3i. Or what? Minus 2 plus 3i or minus 3i?
Minus 3.
Minus 3. So maybe my interpretation is, when I take the say negative of a complex number, so both real and imaginary part, the sign of the real and imaginary part gets flipped. Okay, so this is what I want. So this is easy to implement. Now in this case also, what are the options? What are the options here?
As a
What
member
is the
function.
translation here? D equals, what will be the translation?
A dot operator minus.
A dot operator minus, and then
No arguments, just parentheses.
now can you see that already we have overloaded the operator minus method. So here also we are overloading the operator minus method. Is there any conflict? So how it distinguishes the difference, whether it's a unary or binary?
By number of arguments.
Number of arguments. In case of binary, you definitely require another argument here, right, to be passed. But if it is unary, the only operator that is already invoked, so nothing need to be passed here, so it is void. So that makes the difference. Is that fine? So in the same code, you can have unary minus, binary minus both overloaded, but the number of arguments that you pass in those overloaded copies will definitely differ. Is that fine? What is the other option here? So this is a member function option. Can we have the friend function option also in the unary case?
Yes, sir.
What will you pass here? There is only one argument, so all the arguments, all the operands need to be passed. So this is the only one operand. So this is a. So both of these may be there. I mean, you may wish to include both of these, and internally the only thing is you have to change. Say if it is c dot imaginary, you have to write minus of c dot imaginary. Or if it is say t dot c dot real, it should be right. You should write like that. So you can write the details of the implementation. What about the unary minus minus? What do you expect? This is a pre-increment. What do you expect?
C dot operator plus plus.
So it should be now after the increment. What will be the value of c? 3 comma 3 plus
3i.
3i.
And what about the post increment case? What would be the post increment case? Okay, let us write it here. What do you expect if it is a post increment? So this is what C means, right? So after the post increment, C will be
4 plus 4i, 3i.
I mean, considering these to be the same. I mean, earlier it was C equals to 2 plus 3i. Then after the post increment, C will be
3 plus 3i.
And then what will be the D?
2 plus 3i.
D should be 2 plus 3i because this is post increment. That means you first assign the initial state of C to D and then you increment C and modify it, right? So now can you tell me that what will be the translation in this case? What translation will take place here? Or in other words,
dot operator plus plus.
C dot operator. Do all of you agree with this? And how many arguments will be passed here?
0.
0. So this is the operator. So this combination of 2 plus is the operator symbol and the operator keyword is there. So that is how the operator function is named and C is invoking it. So that much. And what is the other option? Can we have the friend function option here also?
Yes, sir.
And in that case, it will pass this. Do you all agree with this?
Yes, sir.
Now internal details I am coming to that later on. But what about this one now? So if I write the member function option, so it will be C dot operator. What will be the name?
Plus plus.
Plus plus. Can you pass? Do you pass any argument? No, because he is already passed. So now can it make a difference between these two? Can it make any difference between these two?
No, sir.
Got the point? If I follow the same logic, so the problem is there. Everybody got the problem? What I mean? Because that's a simple logic we are following each and every time, right? So this also will have conflict with this one. How to resolve the conflict?
We can pass an additional argument in post increment.
So those who are the first time C++ coders, can you feel the problem? Till now, the logic was very simple. So you have got some operator symbol. So you write the operator function name as operator keyword followed by the symbol. That's all. And we know that both the options are supported, both the member function and friend function. So that part was fine. But now if it is in case of a pre-increment, post-increment, you are using the same operator symbol for both. But based on the position of that, either it is in the beginning or the end, the implication differs. The implementation also will differ. So how to make the distinction between these two? So you cannot just revisit the entire rule that we have just now framed. Rather, the easiest way to do this is to do what? Because now if you have to rethink it, it will be a complete mess. So the best thing may be that you still, so here you pass a dummy integer value and here you also pass a dummy integer value. Are you getting the point? So there should be some tie breaking or kind of some mechanism through which the compiler can distinguish between these two. So now if you add this dummy integer in both the cases, so in this case it will be just having one integer, in this case apart from C it will have the integer. So this dummy integer helps the compiler to distinguish between these two conflicts or to avoid the conflicts. Is that part clear? A dummy integer is added in the argument list in case of a post, say decrement or increment, whatever, the post cases. Is that fine? Hello?
We have a class at 11.
Okay. Yeah, you have a class. Okay, I think you can write it now. So in the next class we'll see how to write the details. Okay, then I'm leaving. Thank you.